what's up everybody? Welcome to lecture 13 part 2. Before we really got into everything, I wanted to challenge y'all to try these 4 problems on your own. So what we've got here is this first problem. I just want y'all to prove this equivalence. Show that sine of 3x is in fact equal to all of that. For the next 3 parts, I want you all to find what cosine of 3x is, sine of 4x, and then cosine of 4x. This is just for y'all to try on your own. I'm not going to ask you to turn it in or anything like that, but I thought they were good problems for you to try on your own, to start thinking about things. Having said that, let's get into things. So before we really get into these problems, I wanted to again point y'all in the direction of the lecture notes. They're on Blackboard. If you go under the course material, I think the way I have the folder labeled is as exam 3 notes. If you go there, look at those lecture notes, you'll find a bunch of tables of formulas and identities that you should know. You need to memorize these for the exams. But you should go ahead, insofar as this lecture is concerned, grab it just so that you can follow along more easily. Having said that, for this first example, we want to find the sine of pi over 8. Now, looking at this, I have no clue what the sine of pi over 8 is, right? Like, none of us do. Nobody has that memorized. Or at least I assume nobody has that memorized. It's kind of like the people who memorize pi out to 100 digits. Why? Why would you have that memorized? I don't know. But there is a way we can find it pretty quick and easily. We can start by saying, well, pi over 8 this is equal to pi over 2, or my mistake, pi over 4 divided by 2. Well, now if we go to our tables, we'll find a table for half-angle formulas. And one of them says that the sine of u over 2 is equal to plus or minus the square root of 1 minus cosine u over 2. Okay. Knowing that, what that tells us then is we can think of u, in this case, as pi over 4. So, it must be the case then that sine of pi over 8 is equal to the square root of 1 minus the cosine of pi over 4, all that divided by 2. In a minute, I'll explain why I know to use the positive and not the negative, or why not to write it as plus or minus. Spoiler alert, it's going to go back to the unit circle. So let me rewrite this so it's a little bit easier to read really quick. Like I said, I'll explain why I know to use the positive in just a second. Now, looking at this, we know what the cosine of pi over 4 is, right? It's the square root of 2 over 2. All right, cool, let's write that down. This then is equal to 1 minus the square root of 2 over 2 divided by 2. Well, we can rewrite this now as 2 over 2 minus the square root of 2 over 2, all that divided by 2. Well, this is messy. Yeah, it is, and I'm sorry for that. Well, we can combine this numerator under the radical, combine that as one fraction. When we do that, we're going to get 2 minus the square root of 2 over 2, all that divided by 2. Let me put this in parentheses to make it a little bit more clear. Well, now we can just pull this denominator down to that denominator, can't we? Because this is the same thing as multiplying 2 minus the square root of 2 over 2 by 1/2. So yeah, we can just pull down that 2. When we do that, what we're going to get is the square root of 2 minus the square root of 2 all over 4. And that's it. That's all she wrote. It's an ugly number, I know. Now we could go ahead and clean this up a little bit. Leave the radical just in the numerator and reduce our denominator, but we don't need to worry about that for right now. So how did I know, though, going back to that point I was going to make earlier about why this is positive or negative, how did I know that? Well, I said, I know where pi over 8 lives. Looking at the unit circle, pi over 8 lives about there-ish, roughly, right? About there would be pi over 4, so yeah, around there. So because pi over 8 lives about here, we know that both sine and cosine are going to be positive. For that reason, we knew that we were going to use the positive case of this. Now, what if I had said negative pi over 8? Well, that would be around here-ish, and we need the negative case. Why? Because we're taking the sine, and the sine corresponds to the y value along the boundary of our unit circle. That's all there is to it. Having said that, let's look at another problem. All right, so for this next example, we want to find the cosine of 105 degrees. Well, we have no clue what 105 degrees is, but we do know that 105 degrees is equal to 210 degrees over 2, right? It's 1/2 of 210 degrees. Well, we do know the value of our trig functions for 210 degrees we know them because they're on our unit circle. So because of this, we notice that u equal to 210 degrees, and we know to use another half angle formula. This time, we're going to use the cosine of u over 2 is equal to plus or minus the square root of the entire quantity 1 plus the cosine of u divided by 2. Now notice here, it's plus cosine of u, not minus cosine of u. Slight difference between the two formulas. Okay, we also know where 105 degrees lives. 105 degrees lives in that top left quadrant, right? Where's my chalk? Right there. On the unit circle, 105 degrees is going to live somewhere up here, right? Well, that means cosine is going to be negative because cosine corresponds to the x value along the boundary of our unit circle. And over here, our x values are going to be negative. Okay, so we know that what we're going to have is the negative case. We're going to need the negative square root of everything inside. All right, cool. So putting all of this together then, what we've got is the cosine of 105 degrees is equal to negative square root of 1 plus the cosine of 210 degrees all over 2. Now we know what the cosine of 210 degrees is. It's negative square root of 3 over 2. Okay, so we can now put all of this back together, or rather fill in some more of what exists underneath our radical. What I mean to say is we can now rewrite this as negative square root of 1 plus negative square root of 3 over 2, that entire quantity over 2. Well, we know adding a negative is the same thing as subtracting a positive. So let's drop these parentheses and let's rewrite this to be subtraction. Now, what we've got is going to be sorry, I was thinking for just a second about this. What we've got is going to be 2 over 2 minus the square root of 3 over 2, all of this divided by 2. And I'll show you in a second what I was thinking about. I forgot that negative out front. Well, we can play that same trick we played the last time and combine these two fractions. When we do that, we get negative 2 minus the square root of 3 over 2, all that again over 2. But we can rewrite this now as negative 2 minus the square root of 3 all over 4. And this is where I was thinking. I was thinking about whether or not I should show y'all how to break this up a little bit more. And I think I will. So because we've got the radical being applied to a fraction, we can break that radical up between the numerator and the denominator. What I mean is we can rewrite this as negative square root of 2 minus the square root of 3. All of that divided by the square root of 4. Now, we know the square root of 4 is just 2. So what we've got in the end is going to be negative square root of 2 minus the square root of 3 all over 4. Or, my mistake, all over 2. And this is what I meant in that last problem about we could make that a little bit nicer. We could simplify it a little bit more. Cool. Let's look at the next example. So for this next example, we want to find all the possible x values between 0 and 2 pi, including 0, so that this is true. Okay, before we really get into this problem, there's two things we want to note. The first thing we want to note is we can break this cosine squared x over 2. We can rewrite this a little bit, right? Yeah. We can rewrite this as cosine of x over 2, that whole thing squared. They mean the exact same thing. But when we write it this way, it becomes a little bit more clear that here we're going to want to use the cosine half angle formula. Okay? So if that's the case, we can rewrite all of this as 2 minus sine squared of x is equal to 2 times plus or minus the square root of 1 plus cosine x, all that over 2, and that whole thing squared. Got my little handy note sheet here so I don't miss any steps this time. All right. So what that means then, and yes, I said this time, this is like the second or third time I've re-recorded this bit because there's so many parts, I keep forgetting to write one of them down. It happens. Anyhow, doesn't matter. So, the thing I keep forgetting in the other videos is to point out why we make this next move. So in this next move, what we've got is 2 minus sine squared x is equal to 2 times 1 plus cosine x over 2. Now hold up, wait a minute, didn't we have plus or minus? Yeah, we did. This is absolutely plus or minus, right? But what happens if we square a negative? is positive, right? What happens if we square a positive? It's positive, okay? So the signs disappear. And if we square everything here, well, all of this is going to be positive underneath the radical. So really, we're just getting rid of the radical in that plus or minus whenever we square all of this, right? So now we've got 2 minus sine squared is equal to the quantity 1 plus cosine of x over 2 multiplied by 2. Well, now we get to do everybody's favorite part. Cancel that, you suck. And we're left with just, let me write it over here. No, we're right here. We're left with just 2 minus sine squared of x is equal to 1 plus cosine of x. Well, we can rewrite this sine squared as 1 minus cosine squared, and when we do that, these negatives are going to cancel inside, and what we're going to find is this is equal to 2 minus 1 plus cosine squared of x is equal to 1 plus cosine of x. So what did I do here? All I did here was distribute the negative and drop the parentheses. Okay? So now we can try to move all of this to one side. I'm just going to subtract all of this from both sides. Actually, before I do that, this cancels and becomes just 1, right? Now I'm going to subtract all of this from both sides. When we do that, we're going to have cosine squared of x minus cosine of x is equal to 0. Now we can factor out a cosine. And we get that cosine x times the quantity cosine x minus 1 is equal to 0. So what this tells us is that either cosine of x is equal to 0 or cosine of x minus 1 is equal to 0. Well, inside of these bounds, cosine of x can only be 0 at 2 places. The first place is pi over 2. The second place is 3 pi over 2. So what's left then is finding out when this part is equal to 0. Well, this part's only going to be equal to 0, this cosine minus 1. It's only going to be 0 whenever cosine of x is equal to 1. But cosine of x can only be 1 inside of this boundary whenever x is equal to 0. So this means our answers have to be pi over 2, 3 pi over 2, or 0. So x, let's write this out. So x is equal to pi over 2, 3 pi over 2, or x is equal to 0. And that's it. So let's move on. Let's look at another problem. So to tackle this problem, we could start by going back to that original problem I gave at the very beginning of the lecture for y'all to solve on your own, and using those here. So what I mean is we could go all the way back to the cosine of 4x, sine of 4x, and apply what we learned about those here. We can do that by rewriting cosine of 5x as the cosine of 4x plus x. So the cosine of 5x times sine of 4x then becomes the cosine of 4x plus x times the sine of 4x, and applying what presumably you learned because you're good students and you took on those suggested problems at the very beginning of the lecture. So we could go back, apply what we learned from those problems to this, and tackle it from there. But doing those 4 problems, we discovered that means this is going to get messy fast. So surely there's a better way to do this. Surely there's a quicker way to do this. And there is. If you turn again back to the slides, you'll find 2 more tables that are going to be useful to you. One is from products to sums, and the other is from sums to products. And these are just like the table says. They're formulas that help you say, all right, I have a product of trig functions. How do they relate to the sum of trig functions? I have the sum of trig functions. How do they relate to the product of trig functions? We're going to apply that stuff here. Okay, so how are we going to do that? Well, we're going to start by identifying which formula we want to apply. We've got the cosine of 5x times the sine of 4x. Well, I could call 5x u, and I could call 4x v, right? So let's write that down. U is equal to 5x. V is equal to 4x. Using that, in our table, we'll find the very last formula will be the most useful here. The very last formula tells us that the cosine of u times the sine of v is equal to 1/2 the quantity sine of u plus v minus sine the quantity u minus v. Why I grabbed that. So, knowing this formula, we can now apply our 5x and our 4v right in and just solve this outright. It's pretty quick. Doing that, we're going to get that the cosine of 5x times the sine of 4x is equal to 1/2 the sine 5x plus 4x minus the sine of 5x minus 4x which we can reduce to get 1/2 times the sine of 9x minus 1/2 the sine of x. And that's it. That's all there is. Having said that, let's look at one last example. Now, before we jump into this problem, there's a question of the week. If you go to the PowerPoints that I provided y'all, you can use the PDF or the PowerPoint, doesn't really matter. For exam 3, if you look in the PDF or the PowerPoints of, I think it's section 2.3 through 3.2, on slide 63, there's a problem about projectile motion. And in this problem, there are 3 different parts. I want y'all to choose one of the 3 parts, write out the solution for it, scan or take a picture of it, and post it to the discussion board. If for whatever reason it doesn't want to scan or post your image, your solution, then you can type it out. I just want y'all to do one of these 3 problems and then post it on the discussion board. I'll be opening the discussion board tonight, in theory. If it's not open in the morning, just let me know and I'll fix it right away. But again, in section 2.3 through 3.2, slide 63, projectile motion, just do one of those 3 parts. There's A, B, and C, and post it. Having said that, let's get to this. So this problem, we're going in the opposite direction of the way we did the last problem, right? Instead of going product to sum, now we want to go from the sum to product. And the way we're going to do that is by, again, looking at our nice handy sum to product formula table. And you'll notice the 3rd formula in that table. We're going to apply that here. What that formula looks like is the cosine of u plus the cosine of v is equal to 2 times the cosine of u plus v over 2 times the cosine of u minus v over 2. Well, this is going to be easy enough because we can clearly see what u and v are, right? 195 and 105. So, rewriting this, we know that u is equal to 195 degrees. V is equal to 105 degrees. We also know that u plus v is going to just be 300 degrees. And u plus 5. I meant to write u plus v here. And we know that u minus v is going to be equal to 90 degrees. So we can go ahead and just plug u plus v and u minus v into this formula and solve it outright. What we've got is the cosine of 195 degrees plus the cosine of 105 degrees is equal to 2 times the cosine of, well, we just said that u plus v is 300 degrees over 2 times the cosine of u minus v, which we just said was 90 degrees, over 2 we can do some reductions here, and we get that this is equal to 2 times the cosine of 150 degrees times the cosine of 45 degrees This is going to be the square root of the negative square root of 3 over 2. This is going to be the square root of 2 over 2. All of that multiplied by 2. So what we have in the end, well, not quite the end, is 2 times negative square root of 3 over 2 times the square root of 2 over 2 we can bring these two radicals together. When we do that, we're going to get 2 times negative square root of 6, the halves multiplying together, 4, well, this 2 times the 1/4 is going to give us 1/2. So all of this comes out to be negative square root of 6 over 2. And that's it. That's all there is to it. Just massaging the algebra, right? We knew that the cosine of 150 degrees is a negative square root of 3 over 2. We know that the cosine of 45 degrees is the square root of 2 over 2. We know that if we have two radicals multiplying together, we can just put them under one radical and multiply everything inside of them together. So this becomes the radical of 3 times 2, so square root of 6. But we need to keep that negative sign, so we just brought it down. We multiplied our 1/2 together. We got 1/4, left the 2 alone. And then we got rid of the 2 by multiplying it the rest of the way through. And that's it. That's all I've got for y'all today. If you have any questions, by all means, shoot me an email, send me an email, shoot me an email, whatever. Drop by office hours. Yeah. Have a good one, guys.